Okay, soldiering on. We have done 22 of these already. Oh, no. We have done 21 of them already. This is number 22. Okay, now, you know, a spring or no, maybe not a rubber band. You know, when the spring, you press a little bit, what's it gonna do?
It's gonna go back up with.
And then what? It said you hold on one side, you press it, what's it gonna do?
And then after you let go, it's gonna come up and then jump.
Yeah, and then let's say this. Right? You have an object. Let me just draw the spring first. You have a spring that's connected to an object, right?
Yeah.
You press this thing a little bit. Is it gonna come over, right?
Yeah.
Is it gonna stop when back here?
No, it's gonna like go out.
Oh,
and
over
then
there,
back.
then it come back and back and back, right? In this case, the force on this thing, okay, within limit, okay, you can't do crazy about this. Within limit to a spring is proportional to its displacement. Okay, how far you displace this, you put this somewhere else.
Yeah.
Okay, so in other words, F equals to minus this, because the force is always against whatever you're doing.
Yeah.
We just call this constant a K and X. Yeah. This is obviously M x 2 dot equals to minus KX x 2 dot equals to minus K over M x K is positive figure, okay? That. Okay?
Okay.
Yeah, any thoughts how to solve this one?
Wait, what are we solving for?
When you're talking about solving a equation like this, what are you trying to do first and foremost?
Multiply like the dt or d.
Why you multiply dt?
So you can integrate it.
Why do you want to integrate it?
So then, you can like, so you can find the like original equation.
What's the difference between the one difference between the original equation and this one?
The original equation, you can differentiate it and then get like everything else.
Yeah, right. I know. Whatever. But what's the difference between the original equation and this one? I don't know what you can do about it, but what's the difference? One major difference.
Original one's like solve for velocity. Like,
when you do a differential equation, when you look at a differential equation, what's the first thing you need to do? You want to do with it when you want to solve it, or you want to understand it?
Multiply like.
No. A different way to say this in a different way.
Prepare to integrate it.
Yeah, why do you want to integrate it? This is like when you do a function, right? How do you remember a function?
You put in an X and get a Y.
Right. That's kind of thing that ingrained it into your brain, right?
Yeah.
The function is you got an X, you got a Y, right?
Yeah.
And when you do a differential equation, what needs to get into your brain? Ingrain it into your brain, like hamper it in, jam it down your throat kind of thing. I'm jamming it down your throat kind of thing. Not reasonable, but because you're giving all the right good answers, right? Okay, you gotta. When you look at a differential equation, what's the first thing that comes to your mind you need to do? Okay, world, somebody gave up. Yeah, what's the first thing you want to do? Take out the differentials. You don't like these dots. You want to get this into an f x t equal to 0 situation first.
Yeah.
right? And then maybe you get it into x equal to ft. This is different f, obviously, situation, right? And t, right? Oh yeah. I can do this, right? Right?
Yeah.
You can get into the x as a function of t situation, right?
Yeah.
So when you look at the differential equation, what's the first thing you should think?
To get rid of the derivative.
Right, exactly. Okay, get that into your head, really into your head. Yeah. Now, how do we get rid of it?
You can multiply like denominator of the derivative over.
Okay, we're gonna just cheat here. Okay,
Yay.
we call x equal to e lambda t, right? And we're gonna put it in. Okay, because all of these dot equal to something, they all come up to e. Yeah. Of course, you know. Anyway, I don't want to go back and dig back to our notes. Anyway, when we substitute this back in,
Yeah.
what is this? When this take derivative against t twice, what is it?
Acceleration.
No. When x equal to this, right?
Yeah.
x2 dot equals to what?
Oh, it's lambda square e to the power of lambda t.
I think this thing pronounced lambda. Okay, anyway.
Honestly, you should just use like O or whatever.
Okay. I don't want so many ABCDs around. Yeah? So, square equals to minus kn. Both k and m are positive. So what's lambda?
An imaginary number.
Then what?
Square root of k to the n.
Then what?
And plus or minus.
Yay, there you go. Plus or minus. Yeah, good. Okay, now, all right. Okay. We call this thing omega. Okay.
Okay.
Just to screw your mind with some more Greek letters. Okay. Don't call it W. Okay, please do me a favor. Right? When this is when lambda equals to this, right? Then x equals to some kind of a mixture of this. We just say x equals to c1 e I omega 1 t plus c2. No, let's just call it omega t. Okay. c2 e minus I omega t. Right?
Yeah.
Yeah? This is some kind of a mixture. You know what I omega t is? This is equals to what?
It's
What is it?
I have no idea.
What is it? E to the power I theta. This equals to what?
It equals to cosine theta plus I sine theta.
Okay, e to the this equals to what?
It equals to
Here, just think of it this way. Think of it this way. Forget about it. Forget about your cheating chart. Think about it this way, okay? This is the 1, this is the I, right?
yeah.
You have a number here, right?
Yeah.
Right? This is theta, okay? Yeah? right?
Yeah.
It's cosine plus I sine, right?
Yeah.
It's like you go from R theta coordinates, go back to the XY coordinates. Just this is the complex number plane, right? This is the R is 1, right? The theta is omega t, right? So what's X?
X is cosine theta.
What's theta here?
The angle.
No. In this case, we're not doing that. I'm doing in this case.
The omega thing.
Omega what?
T.
Yeah, cosine omega t plus I sine omega t, right?
Yeah.
You probably want to put this in the bracket because otherwise you don't know where that t is. Okay?
Yeah.
Okay, whatever is cosine, this is some kind of a mixture of cosine and sine omega t. Right? Some kind of a mixture. You don't care. It equals to C1 cosine omega t plus C2. These are different C1, C2s, obviously, right?
Yeah.
Sine omega t. Some kind of a mixture or something, right?
Mm-hmm.
Now, we just take a look at this sine omega t and cosine omega t and see what it is. Okay? Sine is like this. Omega t is like this, right?
Yeah.
Cosine is like this. That's cosine. That's sine, right?
Yeah.
So, what is omega t? This is omega t, right? When is the one cycle?
When is a what?
One cycle. When this thing goes a full cycle, that omega t is
Like
what?
over here or
Right. In what? What's this omega t? This is 0. Call this a 0. This is what?
that's like 2 pi.
2 pi, exactly. Yeah, 2 pi. Okay? When omega t goes to 2 pi, it goes to a full cycle. Full cycle. Right? Watch this. That's t equals to 2 pi to omega.
Yeah.
You know frequency?
Yeah.
Frequency is how many times this thing changes in a second, right? Frequency equals to t. This is how many times it moves, right? It's 1 over this time. Yeah. Does it make sense? This is how long it takes to do a cycle.
Yeah.
This is how long it takes to do a cycle. Frequency is 1 over this. If it takes
Isn't that just
0.1 second.
Isn't that just omega divided by 2 pi?
Huh?
If you do 1 divided by 2 pi divided by omega, isn't that just omega over 2 pi or something?
Yeah. That's what I'm trying to do. If the period is 0.1, frequency is 10. What's the unit of frequency?